Hi everyone. The next topic is the topological sorting. Okay, let's see this simple question. Given the graph below, is it a DAG? And if yes, do a topological sort and starting from the node 0, and you can assume the graph is represented as adjacency list and all the adjacent nodes are sorted from low to high. Okay, and you need to show your work. So the first question you have to answer is this graph really a DAG? So yes, it is directed, of course. And another question if you want to check is there a circle? So, well, one of the trick I want to do is, well, to check whether we really have a circle, well, I usually will start this graph considering it to be an undirected graph. So if it is an undirected graph, and then if you see here, and this area could form a circle, and this area could form another circle, right? So if we have an undirected graph, and those two places will be the only two circles, and then if we consider all the edges as directed edges, the next question will be, we want to check those two places again. Oops, come on, let's go back. So, well, we want to check those two places again, and we want to see if they can really be circles. If yes, and then we will say that's not a DAG. So if you check this circle, 0 can go to 8, 8 can go to 4, but 4 cannot go back. So this is not a circle. And if we see this one, 0 can go to 1, 1 can go to 7, 7 can go to 2, but 2 cannot go to 3. So for those two potential circles, after we consider the directions, they are not really circles. Okay, so the next question is, how do we do a topological sorting? Okay, let's start from here. And the trick of the topological sorting is we want to do a DFS again. So let's start to do the DFS. So we're going to start from the 0. So 0 will be gray. Okay, 0 is gray, and then the first adjacent node from 0 will be 1, so 1 will be gray as well. So let me mark the start time 1, and then 2, right? And then 3 here, and then 4 here. Okay, so far so good, and let me change the color to the gray. Okay, so gray and gray. So after 2 is gray, where do we go? We have to go to 5 and then go to 6. So let me do the start point. So 5 and 6. Okay, so after 6, and what do we do? So 6, when we finish 6, there's no other place to go. So what we are going to do is we are going to change 6 to black, and then the end time will be 7, and then let me write down the 6 here. Okay, and then after 6 is finished, and then 5 will be finished. So 5 will be black, and then the 2 will be finished. So the finish time is 9, so 2 is also black. So at this point, we have 6, and then 5, and then 2. And after that, we go back to 7. 7 will be black again, and 10. So 7 will finish. And then 1, we finish at the time of 11. So 1 is finished. Eventually, we go back to 0. So are we about to finish 0? The answer is no, because there is another white node. So we want to go to 3. So start time will be 12. And then we will go to 4. Start time will be 13. Okay, at that time, we have the 3 as a gray. We have 4 as a gray. Okay, so at this point, from 4, there's no other white node to discover, so we want to finish. So 4 is finished. And after that, 3 is finished at the time of 15. So okay, so now we have this 4 and 3 finished. And after that, are we gonna finish the node 0? The answer is no, not yet, because we have to touch the node 8. So we start visiting at the node 8 and then we finish that on the time 17. So 8 is finished. So after we finish 8, eventually we can finish the node 0 and the time will be 18, right? So this will be a topological sorting. So we write all the finished nodes from low to high. And then if we just put all the sequence from high to low, and this will be a result of a topological sorting. And remember, since we have said all the nodes, all the adjacent nodes are sorted from low to high, and from 0 we will go to the 1 first, and then we go to 3, and then we go to 8. So that this is the only correct sequence of this topological sorting given the rule of the how we store the adjacent nodes in the adjacent list. Okay, so this is the example of the topological sorting, and I will see you in the next